Hi everyone, in this video I'm going to be working through a paper 1 question, paper 1 questions. This is the 2022 past paper, but it's really good practice if you're preparing for your mocks or for your actual GCSEs. So I'm going to go through all the questions, show you how I would work them out, show them the workings you need to show. It's an uncalculated paper. Let me know in the comments if you have any questions or anything you want me to have another look at. So let's get into it. So question 1. Change 40 centimeters into millimeters. So this is your converting between units. You have to know these. So I have to know if I want to go from centimeters to millimeters, I would times it by 10. Okay, so you would get part of your mark is knowing that. Not so much in this paper, but you'll see in other papers you will actually get a mark for that part. Okay, so if I want to go 40 centimeters to millimeters, then all I do is I go 40 centimeters times 10 will give me 400 millimeters. Okay, remember when you times by 10, you just add a 0 on. So my answer is 400 millimeters, which they already have there, so we don't need to write that down. So 400. Next up, we have an algebra question. So they say simplify e plus e plus e plus e. So if you were thinking of, let's say, just squares. So if I had a square plus a square plus a square plus a square, I would end up with 4 squares. So it's exactly the same thing here. E plus e plus e plus e. I'm just going to end up with 4e. On the grid, reflect the shaded triangle in the mirror line. So if you have a mirror line, it's really straightforward. All they want you to do is draw on the opposite side. So imagine that this is a mirror. What would the reflection be? Okay, so if it's a reflection, it's going to be exactly the same shape and exactly the same size. So this one, it was 1, 2, 3 blocks tall. So it is going to be 1, 2, 3 blocks taller reflection. And you're going to have a ruler. I unfortunately don't, but it's going to be exactly the same shape. Okay, so that would be your reflection there. Okay, obviously yours is going to be straight, but that's all we have to do for a reflection question like that. In question 4, write down the value of the 6 in this number. Okay, so how I would try and count and try to figure this out, if you didn't know straight away, I would say, okay, so let's write this a bit bigger. Okay, so we always start with our ones or our units, some people call it. So here would be our ones. Then next we would have our tens, okay, because it gets bigger. So it's always ones, then tens, then hundreds, and then we would have thousands. Okay, so we know this is going to be 6,000. So there's a few ways of writing this. You can write 6,000, or you could write it in words. So 6,000. Or if you wanted, you can also write 6,000s. So any one of those is right. Write these numbers in order of size and start with the smallest number. Okay, so whenever you get a question like this, you can see here, this is what we call an FDP question. So fractions, decimals, and percentages. So you can see we've got a fraction, we've got a decimal, and we've got a percentage. Your first step for a question like this, you always have to convert them all to the same unit or to the same form. So convert them all to fractions or convert them all. I usually go to decimals, that's the easiest. Convert them all to the same form. Okay, so because it's an uncalculated question, they have made it quite easy values. So a half, if we write that as a decimal, we would say 0.5. Okay, that's something we should know. Then this one, we're going to keep it in decimal form, so 0.55. And 45%, when you want it as a decimal, all you do is you just say 0.45. Convert it. That percentage symbol is kind of a clue, so that tells you divide by 100. Okay, so 45 divided by 100 would give me that 0.45. And then what I do, if I'm comparing decimals, I want to make sure I have the same number of decimals so I don't get confused. So here, I've got 2 decimal places. Yeah, I've got 2 decimal places. Here, I've only got 1. So what I can do is just add a 0 on. Okay, because then we can see I'm comparing 45, 55, and 50. So we would have to write this in order from smallest to biggest. Okay, so I'm going to just write it on the side here. So the smallest one is obviously that 45, so 0.45. Then next we've got 50, so 0.50. And then next we've got 0.55. And then the only thing with this type of question is they want you then to write it with the original numbers. So write it with the fractions, decimals, percentages. So that 0.45 was originally 45%. That 0.50 was a half. And then that 0.55 was 0.55. Okay, so we've reordered it. We just changed it to decimals so we could see it a bit easier. But then in the final answer, this is what they want. So this is how they want the final answer with the fraction, with the decimal, and with the percentage. Okay, so that would be that question. They ask this question in every single paper, so it's really important that you get the hang of that. Make sure if you see a question like that, convert it all to the same form, write it in the order, and then use the original numbers again. Question 6, we have the pictogram gives information. The pictogram gives information about the number of hours of sunshine on a Saturday and a Sunday. We want to know how many hours of sunshine they were on a Saturday. So with a pictogram, what we first got to do is look at our key. So they say every sun represents 2 hours. So what I would do is I'd go on to Saturday and I'd say, okay, this sun is 2 hours. That one is 2 hours. That one is 2 hours. That one is 2 hours. So how many hours of sunshine do we have in total? So 2 plus 2 plus 2 plus 2. So we have 8 hours in total. Okay, then we have question 7. Simon buys some candles. Each candle costs £2. He pays with a £20 note and he gets £6 change. So work out the number of candles he buys. So first of all, let's just work out. So he paid £20. £20. Take away how much he paid, we don't know. And he got £6 change. So that means how much did he spend then? So if I give in a £20, I get £6 change. That means I spent £14. Okay, does that make sense? So £20 take away 14 would give me £6 change. So that means he spent this much. So he spent £14. So £14, we want to divide that by how much each candle costs. So £14 divided by £2 will give me how many candles he bought. So he bought 7 candles. Then if we look at question 8, the bar chart shows information about the total rainfall each month for 4 months in a city. So as soon as I see a bar chart question, what I go do is I label each bar. So what is the value of each bar? So if I look at this one here, January, I've got 5, 10, and then I would assume I'm going to say that's about 12. It could be 13. February, again, it's halfway, so maybe 17, 18. March, I've got 30, probably 32 there. And April, if I read off the value there, I've got exactly 40. Okay, and they want to know, let's see what the question is. In May, the total rainfall was 35 centimeters. In June, the total rainfall was 20 centimeters. Okay, so we don't actually need those numbers. First of all, they just say complete the chart. Okay, so let's fill in May. So in May, we said the rainfall was 35. So I'm going to go to May. Remember, we have to go into this block. I'm going to go to 35. Okay, again, I don't have a ruler with me, but you would have a ruler, so you would just draw this in really nicely. Just make sure you stick it in that column. Okay, yours would be a lot neater than mine. You can colour it in if you want to. You don't have to. You could just draw it. Okay, so that is 1 mark there. And then they say in June, the total rainfall is 20. So again, you're going to go to the June column. You're going to draw across at 20 like this and draw down with your ruler. Okay, and then you can colour in or you don't have to. Then let's look at the next question. So Rupa says, in February, there was 15.5 centimeters of rainfall because the bar is half a square above 15. So let's look at February. So she says that we had 15.5. How you got to say this is kind of not possible, because if I look at just the first one, let's look at the first. So here, this would be 1, then 2, then 3, then 4, and then 5. Okay, so you can see each of these little blocks, it's counting in ones. So I wouldn't have 15.5. We can see in February I've got 15, 16, 17, probably about 18 there. Okay, so we can say Rupa is incorrect. We could say the rainfall in February is 18 centimeters or 17 centimeters. Okay, so either of those would be okay because it's not exact. So that is our reason. So we can say she is wrong. It's not 15.5. It is 18 or 17 centimeters. Another reason would be the square is divided or is split into ones. Okay, it's split into 5 ones, not into halves. Okay, so any of those reasons would be okay. But I would say probably the easiest is just to look at it and say, well, 18 is actually the rainfall, so it can't be 15.5. Let's have a look then at question 9. So here is a sequence of patterns made. Draw pattern number 5. Okay, so what I would do first in a question like this is I would just label how many blocks you got. So number 1, we've got 1 block. Number 2, we have 1, 2, 3 blocks. Number 3, we've got 1, 2, 3, 4, 5 blocks. You can kind of see the pattern here. We've got 7 blocks next. 1, 2, 3, 4, 5, 6, 7. So you can see counting in odd numbers. So 1, 3, 5, 7. So we can expect the next one is going to have 9. And you can kind of see we're adding on 1 going down and 1 going across every time. Yeah. Which means if we draw pattern number 5, we are going to have, so we had 1, 2, 3, 4 going down, 1, 2, 3, 4 going across. Now we're going to have 5 going down, 5 going across. So we can have 1. Yours would be with a ruler, so it's going to be a bit better than mine. My drawing's not so great on this drawing pad. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, let's just count. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9. That's what we wanted. So that is going to be pattern number 5. Generally, I see students are pretty good at questions like these. Let's see what else we got. So complete the table. Okay, so we already figured this out kind of when we were drawing it. So we said it goes, the first pattern has 1, next pattern has 3, next pattern has 5, next pattern has 7. And then if you didn't know this, you could just count on what you've drawn on number 5, but we knew it's 9. And then the next thing, so 5, 7, 9, next is going to be 11. If we look then at question 10, so they say in Norway last year, the lowest temperature was minus 15 degrees Celsius. And then in Norway last year, the highest temperature was 42 degrees greater than the lowest temperature. Work out the highest temperature in Norway last year. Okay, so what they are trying to trick us here is I would try draw a number line. Okay, it doesn't have to look pretty, it doesn't even have to be straight, as you can see. And we can say the lowest temperature was minus 15. And now they say the highest temperature was 42 degrees greater than this. So what we need to do is we need to add on 42 degrees. So you could count each of these. I'm not going to draw them all because that's going to take us forever. But what we just got to keep in mind is that this is 0 degrees Celsius. So I'm going to add on 42 degrees. So if I add on 15 here, that will get me to 0. And then I've still got to add on a little bit more. So let's just do 42, take away 10 is 32, take away 5 is 27. Okay, so I'm going to have to add on another 27 degrees here. Okay, because if I do that, that means in total I've added on 42. Okay, if you add these two up, it means in total I've added on 42 degrees, and so I'm going to get my highest temperature, the hottest temperature was 27 degrees Celsius. You might have been able to do this straight away. The reason why I did it with this number line is just lots of people get tricked by this minus 15. So just remember, it's negative 15. You're going to have to add on to get to 0 and then keep on adding. Okay, so the hottest temperature there is plus 27 degrees. You could also write it out in words and just say minus 15 degrees Celsius plus 42 degrees Celsius. And you're going to get positive 27 degrees Celsius. Question 11. At the end of October, Fiona's electricity meter reads 88,738 kilowatts hours. And then at the end of November, her electricity meter reads this. Okay, let's highlight these two values quick. Each kilowatt hour of electricity that she uses costs 16p. So we want to work out how much she had to pay for her electricity she used in November. So they ask questions like this a lot. How you work them out is you need to work out how much electricity she used. So let's just write that out. So how much electricity? So obviously, if you were working out your electricity, how much you used in a month, you would say, well, at the end of this month, my total was 89,198. At the end of last month, my total was 88,000. So if I work out the difference, I'll know how much I used just in this month. Okay, it's a non-calculated paper, so we're going to write it underneath each other like this. And then we go 8 take away 8 is 0. 9 take away 3 is 6. 1 take away 7 we can't do. So we're going to borrow. So let's cross out that 9. Make it an 8. And then this becomes 11. So 11 take away 7 is going to give me 4. 8 take away 8 is 0. 8 take away 8 is 0. So we can see then we used 460 kilowatt hours in November. Okay, we can then work out how much that costs us then. So the cost is always how many kilowatt hours did we use times the price. Okay, so we used 460 kilowatt hours and we are going to times that by 16p. Okay, so however you do your timesing, so some people will do this column method, some people will do the grid method, whatever works for you, whatever multiplication works for you. So if we multiply this out then, with this method that I'm using, the column method, how we go is we go 6 times 0 is 0. 6 times 6 is 36. So we put the 6, carry the 3. 6 times 4 is 24. Add the 3 is 27. Then we work in the next column. So we're working with the tens then. So we add a 0. We say 1 times 0 is 0. 1 times 6 is 6. 1 times 4 is 4. And then all we've got to do is add that up to get our total. Just keep in mind this is in pence. So 0 add 0 is 0. 6 add 0 is 6. 7 add 6 is going to be 6 add 6 is 12, so 7 add 6 is 13. Carry the 1. 2 add 4 is 6. Add 1 is 7. So that is 7,360 pence. And then another mark that you're going to get then is converting that. So our cost is 7,360 pence. Let's just see if they want us to give it in pounds. Okay, so they don't actually say, so you could probably leave it in pence as long as you did it like this. If you wanted to, you could also say, if I just divide this by 100, I'll get my answer in pounds. Okay, so remember, if we divide by 100, what we do is we go to the back of the number and we just jump 2 spots. So then it would be 73.60 pounds. But this one, I think they would have had to have given you the mark if you left it in pence as well. Question 12, we've got a fraction question, which we always get a fraction question. So they want us to work out these two fractions added together. So 4 fractions, the first thing you have to do if you're adding, you have to make sure the denominators are the same. Okay, so that's the bottom numbers have to be the same. So what I would do is, we can see we've got this 5 over 12 here. I'm going to try and make the second number something over 12 as well. So 1 over 6, we can use the equivalent fractions. So equivalent fractions, what we do is we say, I want it to be something over 12. Okay, so we just got to figure out what did we do to the bottom, and we do exactly the same thing to the top. So I want it to be 12, so I would have to go times 2. So at the top, I have to then go 1 times 2, so I get 2. So what we've done here is we said, whatever there's 1 over 6, we can rewrite it as 2 over 12, and it's exactly the same thing. Doesn't change anything, but it does help us. So I'm going to rewrite this problem. So 5 over 12, keep that. And instead of that 1 over 6, I'm going to write 2 over 12. Because you can see it's already so much easier now. If I'm adding fractions, the bottom just stays the same. So it's going to be 12 at the bottom. And at the top, I just go 5, add 2, gives me 7. And that is my final answer for this one. Okay, so that's a really important thing. If you're adding or subtracting fractions, make sure the bottom is the same. And then you just do normal adding or subtraction. 12b, they want us to work out this multiplication of fractions. If they give you multiplying with fractions, you can celebrate, because it's a really easy one. So all we've got to do for this is, when we're multiplying fractions, let's get this written out a bit bigger. All you have to do is you just go multiply top times top. So 3 times 5 is going to give me 15. And at the bottom, 10 times 8 is going to give me 80. Okay, so like I said, really straightforward if they give us multiplying. They want us to then give it in its simplest form, which just means, can we divide both of these numbers by some number that's the same? So in this case, we can simplify it. So let's divide the top and the bottom by 5. Okay, what I do is, if they ask you to simplify, try always check, can you divide by 2? Can you divide by 3? Or can you divide by 5? Those are good ones to start with, because you can usually divide by one of them. We have to do the same at the top and the bottom. So 15 divided by 5 is 3. 80 divided by 5. So 40 divided by 5 is 8. So 80 divided by 5 is 16. Okay, and that is our simplest form. So that is where you would get your second mark there for that one. Okay, but even if you forgot how to simplify, if you see a multiplying question, make sure you can do this first part. Just multiply top times top, bottom by bottom, because that's a really easy mark there. Okay, let's have a look at question 13 then. So there, this looks probability. There are 15 sweets in a jar. Four of the sweets are red. Jill takes a random sweet from the jar. Write down the probability that the sweet is red. So with probability, how we're going to think of it is, if I want the probability of a red sweet, the probability of red is going to be, how many red are there out of how many are there in total. Okay, so really simple. This one, there are 4 red sweets. How many are there in total? There are 15. And so that is my probability. That's all you have to do for that. Next up, there are only green counters and blue counters in a bag. A counter is taken at random from the bag. The probability that the counter is green is 0.3. Find the probability that the counter is blue. Okay, so with probability, if you add up probabilities, it always has to add up to 1. Okay, so if I've got 0.3, let's say we're going to say green plus blue has to give me 1. So I've got 0.3 green. I need to work out what must my blue be so that I can get 1. Try to think of this, if it's confusing you with the 0.3, just think of it as 3 and then think of this as 10. Okay, so 3 plus what will give me 10? 3 plus 7 will give me 10. Okay, you just put a 0 in front of it. Okay, so that is my probability that it is blue. Next up, we have an algebra question, question 14. So, y is equal to 6x minus 5. And they want us to solve for y when x is 4. So this is a really nice question when they give you one like this. So when x is 4, all you've got to do is wherever you see x, you're going to put a 4 instead. So in this case, we are going to have y is equal to 6 times 4. Okay, because they don't put it there, but actually it's 6x is 6 times 4. So 6 times 4 minus 5. Now you're just going to work it out. So y is equal to 6 times 4 is 24. Take away 5. And if I work that out, 24 take away 5 gives me 19. So y is 19. So if they give you a question like this and they tell you x is something, that's what you're going to really celebrate. You're just going to chuck in that value for x wherever you see x. And then question 15. Work out an estimate for the value of 92 times 1.63. You must show all your working. Okay, with these types of questions, what we usually try to do is we try round to one significant figure. Okay, so whenever they say estimate, you've got to be really careful for these ones. Okay, so estimate means round both numbers first to one significant figure. Okay, it just means round it so that you'll get a feel for these. So let's do this one so you can get a feel for it. So 92, we're going to say 92, we could round that to just 90. Okay, that's really close to 90. That would make more sense to work with. It's going to be easy to multiply. And then 1.63, if I was going to round that to a sensible number, I would just say that is kind of close to 2. Okay, so we could just say, so you can see we're just rounding it to one significant figure. So we're saying this 90 is the most important thing. So I'm just going to round it to 90. And this first number here, the decimals aren't really that important. So I'm just going to try round this one. So 1.63, really close to 2. So with an estimating question, you do the rounding like that first. And then what you have to do is you just work it out. So instead of this 92 times 163, we are now going to go 90 times 2. 9 times 2 is 18. We just add a 0. So that is our estimated answer to this question. So when they say estimate, it's just, they don't want you to work it out exactly. They just want you to give kind of a close figure. What could be, where would that be around? And then let's see. So they say, given that this 2.96 times 3.2 is 9.472, find the value of this. 29.6 times 32. You can see the numbers are very similar here. So we've got 2.96 and then we've got 29.6. Those are very similar. They just shifted the decimals a bit. And then the same thing for the second one. So 3.2, 32. So you can see they are very similar, which is why they've given it to you. So what they want you to do is work out. So we know it's probably going to be something with this number. So I'm just going to write that number, 9472. We've just got to figure out now where the decimal would be. So your trick with multiplying with decimals is if you have a decimal in the question, like here we've got one decimal place, in your answer you're going to have one decimal place. So you're just going to put it here so that you got one decimal place. Okay, so that is really, they've given it to you. They just wanted you to see that the numbers are very similar. All that's different is the decimals. So you can kind of work out like that. You could then go and work out 29.6 times 32. You could work it out manually and get this answer as well. But they've tried to help you out here. That's why it's only 1 mark, because they don't actually give you any marks for this working out. I'm going to work through the rest of the questions in the next video. Please let me know if you have any comments, and thank you for watching.